Right, so this is the Year 8 periodic table knowledge test. So it's all the answers for the test that you're then going to be doing at the end of the unit itself. Right, label the periodic table of elements. Right, so what I'm going to do is I'm just going to write down at the bottom here, I'm going to write down alkali metals, and I'm going to put 1 at the front. I'm then going to do number 2 is the transition metals. And then I'll change the colour and I'll go 3, the halogens, and I should have changed the colour between them and the others as well. Number 4 is the noble gases. Okay, right, so alkali metals is this column here, number 1. Transition metals, okay, again, like I said, I should have done it in a different colour really, is kind of this block here. So that is number 2. Number 3, got the halogens, that is this column here. And number 4, the noble gases, is that column there. Okay, they're the main kind of labels on the periodic table. Question number 2, define an element, compound and mixture. So an element is one type of atom. Okay, so for example, sodium is an element and it's just one individual type of atom. A compound is 2 or more elements chemically combined. And then a mixture is 2 or more elements not chemically combined. Right, now the biggest point of this is the element's quite straightforward, but a compound and mixture is a compound is chemically combined. So that means they are stuck together, which means you can't separate them very easily at all. A mixture is not chemically combined. Right, so what you could have is you could have a class where I say everybody hold hands with somebody, right, and hold hands as tight as you possibly can. That is being chemically combined, they're hard to split up. If you've got a mixture, what they've got is everybody's individual, and what I could do is I could separate the class very, very easily. Right, so label the diagram, show what the numbers mean. Now this is a kind of a little bit weird, right, in the fact that this diagram here, right, is upside down compared to what is often done. Right, and you just got to be aware that it could be kind of mingled around, or you could even get lithium 7,3 or the other numbers the other way around. Right, so what I'm going to do here is I'm going to circle that number, and circle that number. So it's kind of like the biggest number. The biggest number is the mass number. The smaller number is the atomic number. Okay, then these all kind of link in together. So if I just do, what color should I do? Blue. Oh, click on the blue. I've done it in green. Is the symbol, and then that there is the name. Okay, so draw the electron configuration of an atom of fluorine. First thing we need to do is we need the symbol and we need the numbers. Right, then what we need to do then is I'm just going to do it underneath here. I'm going to do the pen. Right, so the pen is then the number of protons, electrons and neutrons. Protons is 9, it's that number there. Electrons is the same, number at the bottom, or the smaller number. And neutrons is 19 take away 9, which equals 10. Number of neutrons. Now for the purpose of this activity, we don't need to know that, and we don't need to know that. All we need is the electrons at 9. So I now draw fluorine, and I do the first shell. Right, and what you've got to do is you've just got to remember that 2 electrons go in the first shell. And once there's 2 electrons in the first shell, we've then run out, right? There's no more space in there. And we've now got 7 electrons left. So as soon as that shell's full, what you then do is then you draw another shell, which is obviously should be a circle. I've got 7 electrons and I go 1, 2, 3, 4, 5, 6, 7, nicely spread out in pairs, and so there is then one gap left. If I then had more electrons, right, then it went to 8, then I'd have to draw another shell in after the 8. The electron configuration of fluorine is 2, 7. Okay, so describe your observations when you add a piece of sodium to water. It will fizz. Okay, so what it will do, it kind of go molten, molten, right? It might catch fire, and if it does catch fire, it will kind of be like a yellowy orange flame. Right, they're the main observations when you add sodium to water. Question number 6. Explain why the reactivity of group 1 metals increases down the group. So you've got group 1, you've got lithium, sodium and potassium. Right, and what they all want to do is they all want to lose the outer electron. Right, and it's basically which one loses it the easiest. Right, so size. The bigger it is, the easier it is to lose the electron. So big loses easier. The attraction. Okay, the bigger it is, the less attraction. Okay, so the attraction is between the electron on the outside and the middle. The last one is then shielding. Okay, so the bigger it is, the more shielding. And what shielding means is things in the way. So if you think about a classroom, right, if I've got the inner electrons that are kind of my front desk, right, I can see what they're doing all the time. The people on the outer desks, what I can't do is I can't see what they're doing all the time. So they've kind of got more kind of leeway, and if they wanted to, they could probably sneak out of the door easier, even though that would never happen. So reactivity down group 1, right, it goes lithium, sodium, potassium, and potassium is more reactive because it's bigger, it's got less attraction, it's got more shielding, so therefore it's more likely to lose its electron. Explain why the reactivity of group 7 decreases. So we've got fluorine, chlorine, bromine. Right, so this time it is how easy gain an electron. All right, so fluorine can gain an electron easier because size, smaller it is, the more reactive. The easier it is to gain the electron. It's also got less attraction the further they are away. Okay, so I could even change that to more attraction, makes it more reactive. The third one is to do with shielding. Right, the more shielding, the less it's likely to gain it. So shielding, the less shielding, the more reactive. Explain why neon is not very reactive at all. It has got full outer shells. And if it's got full outer shells, therefore it doesn't want to gain it, doesn't want to lose an electron. Keywords, right? So if I've then got the periodic table, a vertical column is called a group. Okay, should really put in there a horizontal row is a period. Okay, but we won't add that one in, it's just for information. Another name for the group 7 elements, okay, we talked about that before, is the halogens. The elements on the right-hand side of the step line of the periodic table are non-metals, so therefore on the left-hand side are the metals. Right, again, what you've got to do is you've got to recap. Biggest questions, right, and I've kind of just sort of talked about it, is the reactivity down group 1 and down group 7, right? You need to understand, right? Even draw them out, picture them, right, and work out exactly what I'm talking about. Because out of this entire topic, that is probably one of the most likely questions that's going to come up. Okay, even whether it's at the end of year 8 or the end of year 11, it's a likely one. Now you need to go away, right? And what you then need to do is you then need to look back, write it all down, go through the blank video, test yourself, test yourself, test yourself.